Okay, it's recording. So, did you get the yesterday lecture? I mean, the recording of yesterday lecture?
Yes,
Yes.
Okay, right. So we actually discussed the advantages and usage of quick written mechanism, right? Now we are going to synthesize or develop or model the quick written mechanism based on certain conditions. Okay, so what the important thing in designing the quick written mechanism is the time ratio. Time ratio defines uh, the ratio between the forward motion time and backward motion time, right? So how much time the mechanism will take from its initial position to the final position. This you can call it forward motion and forward time, okay? Uh, and how much time it will take to return back from final position to the initial position, that would be called as backward time, okay? So time ratio defines actually these two, to the ratio of these two times. Okay, as I told you, time ratio could be forward time over backward time, or vice versa. It could be possible as well. But I would always prefer just use one convention. If it is not mentioned in the question that for a time ratio is forward over backward, or backward over forward, just take one convention, and the convention is forward over backward time. Okay. Uh, so the question says that we need to design a 4-bar mechanism, as in example number 1, which we already discussed. But here we need to provide a time ratio of 1:1.30 with 45-degree output rocker motion. Okay. So time ratio is defined, as I told you, this is 1/1.30. It means forward time, or I can say backward time, is 30% more than the forward time. Okay, this is actually not quick written. Actually, it's a quick forward mechanism. So it's going very fast uh, to from initial position to the final position and coming back to the initial position slowly. Okay, uh, there is a possibility for this kind of mechanism. For example, a mechanism, a robotic arm, for example, right? A robotic arm is from initial position, it is going to final position and take out some weight, right? And coming towards the initial position and put it there. Okay, it could be possible like this one. So in this case, from initial position to the final position, it is actually, it doesn't have any weight, extra weight. Okay, so it can go with higher speed, but once it is taking the weight from final position to the initial position, it can come slowly. Okay, uh, so now I need to do the calculation, some calculations here. By the way, I mean, let me just I modified these values. I intentionally did not modify these values, just to let you know that how we can calculate them. Okay, so time ratio is nothing but the ratio of alpha and beta, right? Where alpha, you can see in the diagram on the right hand side, alpha is the angle. I'm sorry, this is a huge problem here. Yeah, so alpha is the angle from this line, which is B1 and O2. I'm not stating which line is this one. Just remember that B1 and O2, and there is another line which is B1 prime and O2, right? So the angle between these two lines is alpha angle. Okay. Um, here, alpha is also called forward angle, forward motion angle. You can say this is forward motion angle. Okay. On the other hand, beta, you can see here, it is um, again the angle between O2 B1 and this one, this line, right? So this is O2 B1 prime, but this complete angle, right? So this is a complete angle from here to here. So this is called backward motion angle, okay? And you can observe from the figure that alpha is less than beta, right? So it means for forward motion, the time will consume lesser as compared to the backward motion, okay? So alpha and beta we define, and if you add alpha plus beta, definitely it becomes complete cycle, which is 360 degrees, okay? So let me just try to do the calculation here. So I have a class now. Okay, come after the class, please. After 10:15. Okay, so time ratio equals to 1 over 1.30. So it is alpha over beta. So I can say alpha equals to 1.30 of beta. Okay. No, it should be, yeah. I'm sorry, 1.30. Okay, divide by, right? So this is the first equation we have. And the second equation is this one from 360. I'm sorry, so this is the first equation. Now I can write the second equation, alpha equals to 360 minus beta, right? Okay. So you can compare both equations here. So beta over 1.30 equals to 360 minus beta, okay? If you calculate beta from here, I guess it is 203.5 degrees. So you can confirm this value, okay? 203.5 degrees. And once you put back in any other equation, so this, let me call it, this is equation number 2, any equation, so alpha will become 156.5 degrees, okay? So from the time ratio, we can calculate forward angle and backward angle, okay? There is another important angle, which is called construction angle. I will explain you while we will draw the mechanism, right? We will synthesize the mechanism. What is the importance of this delta angle? Delta angle is actually either 180 minus alpha. It's an absolute angle. It is always positive angle, or 180 minus beta degrees, right? So in this case, if you put the value of any either alpha or beta, so delta would be equals to 3.5 degrees, right? So you can check these values later on, right? So now we have alpha, beta, and delta. So before starting the synthesis of quick rate mechanism, we need to calculate these values based on time ratio. Okay. Now let's proceed. So now here we need to draw the mechanism. Okay. So let me just read the first step for you, and then we'll move towards our drawing. Okay. It says that draw the output link O4B, right? O4B is the rocker, right? In both extreme positions in any convenient location, such that the desired angle of motion θ4 is subtended, right? Okay. It means attained, right? Or obtained something. So in the question, θ4 is given how much? 45 degrees, right? Okay. Degrees, right? Now I need to draw this link. This is the initial position of the rocker. Initial position. And this is the final position, right? Okay. Exactly similarly, I mean, exactly same what we used in example number 1, right? So we need the initial angle. What we took initial angle?
So 60.
60 degrees, right? So this is 60 degrees we took, and the initial length we took I think 40.
50.
Yeah, 50 millimeter, or let's take 40 millimeter.
50.
Okay. Yeah, 50 millimeter. Okay, let's take 50 then. Okay. So now I need to draw this line in both extreme conditions. Okay. So let me just put this one. So first, what we need the origin, right? So I can, let's say, draw here. So this is the origin here. Let me just draw the 60 degrees. So this is 60. Now I can draw the, okay. So this is 50. No, it should be. I'm taking 40 millimeter because otherwise it would be probably out of my drawing area. Okay, so just write 40 millimeter. Then I need to rotate it by 45 degrees, right? So 60 plus 45, that would be 105. So this is 105 here. Again, I can just rotate it here. So sorry. Approximately. Okay. So these are the initial and the final position of the rocker. You can label them. Okay. The second point is calculate alpha, beta, and delta using equations 3.1 and 3.2. In this example, alpha we already calculated, right? So let me just show you the steps. So we already, by the way, these values are not correct. I corrected there in the slides, but this is not updated slides. So alpha, we calculated 156.5, beta 203.5 degrees, and delta is 23.5 degrees. Okay, so we already calculated. The third step is draw a construction line through point B1 at any convenient angle. Okay, so which line? This is the construction line we are talking about. Let me highlight this line we are talking about. Okay, so at any angle, at any convenient, we can draw the line. So let me just So B1 is the extreme point, B1 and B2. Okay, so I'm drawing just at certain angle here. Okay, so graphical method needs actually a lot of patience. So nowadays we have softwares to draw the to do the kinematic analysis of the mechanisms, but all these softwares actually either based on graphical analysis or analytical analysis. So that's why we need to know that how graphical method actually works, right? Because in reality, we need to use both methods, analytical and graphical. Sometimes analytical is feasible, that would be our first choice, but sometimes the number of unknowns are more than the equation. So in that case, we need the graphical method. Okay. So anyway, this is the third step. We have drawn the construction line from B1 to any angle. Okay. So the length is also random, so you can choose any length. Now let's come to the point number 4. It says draw construction line through point B2 at angle delta from the first line. Yeah, this is a little bit tricky. How it is tricky, because let me just try to tell you. So we need to put our compass here. Okay, so now it is parallel to line B1 and this construction line. Okay, so what angle we required? Delta is 23.5 degrees. And it should pass. There are two conditions to draw this line, which I'm going to draw. First condition is the angle should be 23.5 degrees, which is delta, and it should pass through point B2. Okay, this is the condition. Okay, so what I can do here, this is a little bit. I can move this protector on this construction line, and wherever these two conditions satisfied, I will stop at that point. Okay. Now, for example, in current position, okay, let me just try to mark something so you will understand. I hope you can see the protector clearly, right? Okay. Can you see it? Can anyone tell me what is the angle now if I draw the line?
So maybe 50.
Excuse me. Yeah, excuse me. Just I need 1 minute. Hello. Walaikum salam. Alhamdulillah. Yes. Yes, Mohammed. How are you? Yeah, Mohammed, could you please call me just after half an hour, because I'm in the class. I'm in the lecture. Okay. Thank you very much. Okay. Sorry for interruption. So, can anyone tell me what is the angle now?
The angle between what, Doctor?
Between the construction line, which I have drawn, and the point. Okay, let me just try to mark. Point B2. Just see the point B2. Okay.
It's kind of 50 degrees.
Yes, very good. It's 50 degrees. Yeah. Okay. Can all of you can confirm that this is 50 degrees?
Yes, Doctor.
Yes, Doctor.
Okay. Okay. So 50 is higher than what we required. We required 23.5 degrees. So what I will do, I will move this protector downward, right? Okay, on my left hand side, I will move so I can get 23.5 degrees, right? So this is the idea, because this is the only thing in this problem which is tricky, which takes a little bit attention. Otherwise, the problem is straightforward. So let me just try to move and make sure that the protector remains parallel to the line, okay? So because it's I mean here it's a little bit difficult for me to match, but I will try to match somehow. Might be you need to draw a couple of lines just to
Doctor,
see the hidden trend.
if we draw a vertical line on B2, it will
Okay.
be easier. Vertical construction line.
You are right, the construction line, but how you can calculate this angle then? Then you need to draw the, you need to calculate many angles in this case. For example, you need to draw the parallel line, okay? Yeah, you can do it. I mean, you can, I mean, this is not, I'm saying that this is the only method which you can adopt. There are other methods as well, okay? But in my opinion, this is a little bit easier. Not so much easier, but straightforward. Let me discuss this one, and then I will come to other methods as well, okay? So, I mean, might be it is so close to this one. Okay, let me just try to see that, okay, how much angle it is. So our target is 20, let's say put 24, okay? Even the 24 is, I mean, still the line is a little bit, I could say that this is, could be the point, right? Okay, so let's see. I mean, for example, here, the problem is I need to mark the point here, okay? The line is not working. I can just mark. So 20. In the software, it's a little bit difficult to get. Okay, so almost this, right? Okay. Now let me try to mark the point here. 270. So this is our intersection point. And at 90 as well, so I can have the complete line. Now let's try to draw the scale here. Let me first draw this point so I can have an idea. Here, a lot of voice actually. Please try to mute your mics. Okay, this is the point. Okay. Could you please mute your mics? Yeah, almost same, right? So you see here, it's exactly, okay. So draw the construction line. I mean, it seems for me that someone is sitting at the seaside because I am listening the waves sound. Anyway, this is the advantage of having online lectures as well, right? As far as you have internet connection. Okay, so this is, let me just try to extend the line. I mean, I wanted to extend the line here as well. Okay, so now we are successful in order to draw this delta angle, right? And it is crossing through point B2. Okay, now let's come to point number 5. Okay, what it says, it's just we already discussed. Label the intersection of the two construction lines O2, right? So this intersection is O2, which I have the intersection of these two lines is O2. Okay. Point number 6, the line O2 O4. So O2 and O4 now defines the grounding. Okay, so we have the grounding. We can measure the grounding here. So this is O4. Unfortunately, I cannot label here. This is the disadvantage of this software. Anyway, so let me just try to. So it is approximately 49 millimeter. So L1 equals to 49 millimeter. Okay. What else we have? Calculate the lengths of the crank and coupler by measuring O2B1. So the crank is O2B1, right? So O2B1 is the coupler, right? And O2B2 is the crank. Okay. So let me just try to solve a measure. So O2 no here yeah, this
I
is
think Dr. the
I need
crank is
yeah
the OTB1.
yeah what we need actually you know, we need to measure what we need. We need to draw take the middle point of B1 B2, right, in example number 1. So let me just take the middle point. So the crank is sorry, this distance is approximately 31, or I can say this is 30 maybe. Yeah, 31 point something, right? 31, let's say. So the middle point is 15.5. Okay, so I need to draw the crank. So I need to draw the crank from this point. And what should be the length? It should be 15 point. This is the problem. I cannot actually reduce it by more than this is the issue. Anyway, so you can understand that this is the crank is how much? L2 is 15.5 millimeter. Okay, you can draw the circle of 15.5 millimeter. How I get this distance? I just measure the distance between B1 and B2 and divided by 2. So that would be the radius of the crank. Okay, we can measure the coupler now. Okay, So coupler could be this distance minus the crank, right? This is the total distance from the center. So I can just take center distance from here, O2 to B1, and subtract the crank, right? So how much this distance? 82, 72. So L3 equals to 72 minus 15.5, okay? So that is 57, 51, 56.5, right? 56.5. Yeah, no, 55.5. 55.5, 6, why? Just wait, please. Let me just calculate it. So 72 minus 15.5, that is 56.5, yes. So L3 equals to 56.5. Did you get the point how I calculated? I calculated from O2 to B1, right? O2 to B1 is crank plus coupler, okay? So crank plus coupler, so I just subtract the, from the total distance, which is 72, I measure, minus the crank radius, which is 15.5, so I got 56.5, okay? Rocker, we assume it was 40 millimeter, right? So what about the Grashof condition? Let's go back to here. We already calculated, okay? So you can see here O2 B1 is coupler plus crank, okay? I measured this one. So if you can subtract the crank from the total distance, you will get the coupler length, okay? And there are some other techniques to draw this one. I'm not going into detail. You can check the other method. We need to check the Grashof condition. The minimum is rocker, right? 40, no, sorry, crank. Crank is the minimum, L2, and the maximum is L3, which is
crank.
no, L3 is coupler, right? Coupler is the maximum, 56.5. Please, you can write these dimensions. Let me write it here so you will understand. So L1, which is the ground, we calculated 49 millimeter. L2, we calculated 15.5 millimeter. L3, how we calculated? We calculated 72 total distance, right? Minus 15.5, which is the crank. It becomes 56.5. L4, we assume it was 40 millimeter, right? Okay. So we have minimum L2, maximum we have L3, right? Should be less than or equal to L1 plus L4, okay? So L2 we have 15.5, L3 we have 56.5, less than 49 plus 40, okay? Definitely it's less than, this is becomes 72, less than 89, right? So by the way, this is the crank is the minimum length, so this is a crank rocker mechanism, right? Okay. Is it crank rocker mechanism? Yes, yeah, crank rocker mechanism. Okay. So it is satisfied. It means you have designed the quick return mechanism, right? Where the forward angle is, forward time is 30% less than the backward time, okay? And angles we calculated. So these are the dimensions, okay? As I told you that there are multiple possibilities of designing this mechanism, but one of the possibility is this one. So this is our design. and this is obeying Grashof condition, so you can use in your practical life. Okay. One important thing is here. By the way, let me just tell you the point number 9. Cardboard model means the physical model, right? I mean, cardboard means you just normally we draw cardboard. Probably I don't know what's the Arabic name, but it's the board which you can use to draw something, to cut something from there, right? It's almost 3 to 4 millimeter thick. Okay, you can make the model from that cardboard, and it will definitely work. Okay. The last point is check the transmission angle. Okay, how we can check the transmission angle here? This is the question here. Why we are first, how we can check the transmission angle, and second question is why we need to check the transmission angle. Okay, can anyone tell me how we can? Please raise your hand. Okay, if you wanted to answer, raise your hand. How we can check the transmission angle? Anybody? Nobody. Okay, let's come to the second question. Why we need to check the transmission angle? Why you are stop talking? Any idea? Okay, let me just ask myself then. Okay.
Doctor, there is no raise hand button.
Yeah. Okay, let me just ask myself. Or you wanted to answer?
I don't have a sure answer, but I will guess.
I don't need the sure answer as well. Okay. So but I need your opinion. Yes, Mohammed.
I think because of the it depends on the make sure it doesn't crash something or hit something when it's moving.
Okay, good. Yes, Turkey Al Rafai.
Yes, Doctor. Can you hear me?
Yeah. Yes.
Yeah. We need transmission angle to know the angle between the coupler and the rotor.
Okay. Why we need to know this angle?
To know the range which can be moved, the mechanism, I think.
Okay. Yes, Khalid.
Because of the limiting position for the mechanism.
For the limiting positions. Do we know the limiting positions of this mechanism?
Yeah, but we don't know the limiting position.
We know the limiting position because the limiting position of rocker is given, right? It will move from initial position to final position by 45 degrees. So if you fix the limiting position of one link, definitely you are fixing the limiting position of other links as well, right? Because they are linked together. You understand? Okay, anyone else? Okay, I mean, if you remember, we discussed knife. Could you please mute your mic? Okay, let me just mute myself. Yeah, it was from knife. Okay, so if you remember, when we were talking about the transmission angle, we said that the optimum range of transmission angle is from 45 degrees to 135 degrees, right? Why we have this optimum range? As I told you that we haven't, I mean, it is not included in your course, right? I mean, definitely there is some analysis, some mathematical equations, some experimental results, which tells us that, okay, this is the range of transmission angle. Okay, we haven't gone into the detail. Okay, but we know that, okay, the transmission angle for 4-bar mechanism should be in this range. So why this range? Because of the forces and so on, the torque and so many things. Okay, so all the 4-bar mechanism should follow this range as well. So this is the answer why we need to calculate transmission angle. Okay, so please remember one thing: whenever you design some mechanism, and it doesn't say, and the question doesn't say about the transmission angle, but it is the responsibility of the designer to check the range of transmission angle as well. If it is out of the range, definitely the designer needs to change the dimensions or something to modify the design of the mechanism. Okay, so this is the thing. Now, how we can calculate? Okay, let's go to the figure again. Okay, so we know that the transmission angle is definitely we have two position synthesis, right? We have two positions of the mechanism, so we will calculate two transmission angles, right? One is at the initial position of the rocker, and one is at the final position of the rocker. Okay, you can see here let me just try to draw this diagram quickly because we have less time. So let me just try to draw here. Okay, so here we have initial position of the rocker, right? And here we have final position of the rocker, for example. And these are two construction lines. Okay, so this I can say this is x-axis, and let's say this is our y-axis. Okay. So the transmission angle would be this one. Let me call it phi 1, and this one, which is phi 2, right? Phi 1 and phi 2, just phi 1 is the initial transmission angle, and phi 2 is the final transmission angle. Are you getting the things, right? This is O2 and this is O4. Okay. So how we can check? Okay, we know this angle. We assume it's 60 degrees, right? And we know this angle, which is 45 degrees. Okay. Let's say this is the triangle. Okay. How we can calculate it? So 60 degrees is, we use different. So this complete angle is 60 degrees, right? Okay. So this is 90 degree. Okay. Can I calculate this angle? This angle, this one, which is equals to phi. Yeah, we can calculate it, right? Okay. And in this case, I'm not sure it is 90 degree. Yeah, this is wrong. I'm sorry for this. It is not sure because we don't know this is perpendicular to this one or not. Okay. Anyway, so we have phi 1 here. We have 45 degrees. We know the length of this link, which is 40. Okay. Yeah. Okay. Let me just try to 60, and this is 45. So we need this angle actually here. Either this angle and this angle. Anyway, I mean, we need at least one or two more parameters to calculate this transmission angle. Okay. we have this length, right? This length is known. Okay. This length is known. Or if we know this length, we can find out this angle, right? Yeah, it's a little bit tricky. I need to work it out. Anyway, you can work yourself as well. I will try to work it, but we can find out by solving this geometry, okay? Somehow we can solve this geometry. Just try to solve this triangle, try to calculate the angles, but I told you that this is phi here, and this is 60 degrees, okay? So this angle, if we can find out, or if we can just calculate the total angle, or this angle at least, right? Let's say this is theta, so we can get this phi 1, okay? So just try to get, okay, how we can solve this side or this angle, and then we can find out phi 1. Anyway, so let me stop here. I will continue in the next lecture. Just quickly take the attendance. Ahmad is here.
Present.
Okay.
Yes.
Ahmad Al-Toijri.
Yes, doctor.
Yeah. Okay. Al-Adham.
Yes, doctor.
Is here. Okay. Turki and Unezi. Turki Al-Unezi.
Yes, doctor.
Turki Al-Rafi is here. Khalid. Yeah, Khalid Maslab.
Yes, doctor.
Okay. Khalid Al-Kahdani is here. Samir is here. Sami Al-Mutairi. Saeed Al-Gahtani is here.
Yes,
Okay.
doctor.
Yes. Abdur Rahman Dakhil.
Yes.
Okay. Abdur Rahman Al-Manham is here.
Yes, doctor.
Yeah. Abdur Rahman, Abdul Aziz Al-Ubaid is here. Okay.
Yes.
Abdul Aziz Sufyan.
Yes, doctor, here.
Okay. Abdul Aziz Saif.
Yes, doctor, here.
Okay. Abdullah Al-Ghamdi.
Yes, doctor.
Okay. Abdullah Al-Zahrani.
Yes, doctor.
Okay. Abdullah Al-Utaibi.
Yes, doctor.
Abdullah Al-Subay.
Yes, doctor.
Ali Al-Kubaisi. Ali. Here. Okay. Omar Al-Juwaid.
Yes, doctor.
Okay. Fahad Al-Harbi is here. Fahad Al-Harbi. I saw his name. Might be somewhere else. Muhammad Al-Harbi.
Yes, doctor.
Okay. Muhammad Al-Halil is here. Muhammad Al-Bakar.
Yes, please.
Okay. Muhammad Rashid is here. Maslat Al-Unezi. Maslat Al-Unezi. Mashari.
Yes, doctor.
Okay. Mansoor.
Yes,
Mansoor is
doctor.
here. Knife is here. Yasir Al-Toijri.
Yes, doctor.
Okay. Nawaf.
Yes,
Nawaf
doctor.
Al-Ghafari. Okay. Thamir Al-Zahrani. Thamir. Yasir Majdad. Yasir Al-Majdad. Okay. Thank you so much. See you in the next lecture. Okay. Assalamu alaikum.
Excuse me, doctor.
Yes.
Yesterday I was present here, doctor.